Did you know that a massive cargo ship moving at just 1 mile per hour has the same momentum as 2,000 cars speeding down the highway? That's the mind-blowing power of physics at work.
That's a fascinating comparison. What exactly makes that possible?
Well, it all comes down to momentum, which is simply mass multiplied by velocity. But here's what's incredible. Even though the ship moves slowly, its enormous mass creates this unstoppable force that would take incredible power to halt.
That's wild. So it's not speed alone that makes something dangerous, it's that combo of size and speed.
So you're telling me we can actually calculate exactly how unstoppable that force is?
Precisely. Let me break it down with a simpler example. Picture a car of mass 1,000 kilograms driving east at 25 meters per second. Its momentum would be 25,000 kilogram meters per second. And here's where it gets interesting. Direction matters just as much as speed.
Direction 2? That makes sense now why crashes from opposite directions are so intense.
How does direction change things?
Well, if that same car was heading west instead of east, its momentum would be negative 25,000 kilogram meters per second. The negative sign is like nature's way of saying opposite direction, same force, different heading.
That really helps explain why head-on collisions are so devastating.
Exactly right, and that brings us to something fascinating called impulse, which is force multiplied by time. This is why modern cars are designed to crumple in specific ways during crashes. They increase the time of impact, reducing the force on passengers.
That's such a clever design. Slowing down the hit saves lives without needing to change the crash itself.
Oh wow, so it's like spreading out the impact over time makes it less intense?
You've got it. And this connects directly to Newton's second law. You know what's really mind-blowing? These same principles that protect us in car crashes also explain how galaxies interact when they collide.
That's incredible. How does that scaling work?
Well, imagine two rubber balls colliding. If a 1 kilogram ball moving at 4 meters per second hits a stationary ball of the same mass, the first ball stops completely and transfers all its momentum to the second. The exact same math applies whether we're talking about atoms or entire solar systems.
It's crazy to think rubber balls in galaxies are playing by the same rule book.
So these principles are truly universal?
Absolutely universal. And here's something that'll blow your mind. When rocket scientists plan missions to Mars, they're using these exact same equations that explain why a golf ball flies off a tee.
That's fascinating. But how do they account for all the variables in space?
Well, that's where conservation of momentum becomes crucial. In space, just like on Earth, the total momentum before and after any collision or interaction must remain the same. It's like a cosmic accounting system that never makes mistakes.
Love that cosmic accounting. Makes everything sound so clean and elegant.
You know, this really changes how I'll think about movement in everyday life.
That's exactly why I find physics so captivating. Once you understand these principles, you see them everywhere, from a child on a swing to a satellite orbiting Earth. Every moving object tells a story about momentum and energy.
Honestly, physics makes the ordinary feel extraordinary. Even shopping carts become cool.
Speaking of everyday examples, this must explain why it's harder to stop a heavy shopping cart than a light one.
Precisely. And here's something most people don't realize. When you're pushing the shopping cart, you're actually experiencing the same fundamental forces that govern celestial bodies. The only difference is scale.
That really puts things in perspective for me.
Same here. Next time I'm at the grocery store, I'll be thinking about Newton.
And you know what's truly remarkable? These principles haven't changed since Newton first described them. Whether we're designing safer vehicles, planning space missions, or understanding how galaxies form, it all comes back to these elegant, fundamental laws of momentum.
This has completely transformed how I'll look at motion from now on.
That's the real beauty of physics. It gives us a deeper appreciation for the hidden patterns governing our universe. From the smallest particle to the largest galaxy, everything follows these same beautiful, predictable rules.